Hello everyone, my name is Ragini and my teammates are Ramya, Swati and Venuta. We are from Sambram Institute of Technology, Department of ECE. We are presenting a project demo, Human Body Posture Monitoring using ARM7 and MEMS wearable sensor. Under the guidance of Professor Kalpavi CY, Department of ECE and Project Coordinator, Professor Yoganandini AP, Department of ECE. Musculoskeletal disorder is most widely spread occupational problems in present societies, industries and services. Musculoskeletal disorder is caused due to compression of bone joints and muscles. It is caused by different risk factors. It is most commonly found among the people who involve in more physical work. In hospital, it is very difficult for a person to monitor a patient who is suffering from musculoskeletal disorder. Each and every patient should be monitored at every moment. While sitting in classroom or while studying as a students, even will not sit in a right position. Only when we realize or feel the pain, will change our body position. Just performing the exercises without proper posture will not be beneficial for a person. Only the right posture and the correct amount of bending or stretches can help a person to get appropriate results. Nowadays, small kids are very much attached to tabs or mobiles. They play games and watch TV from very small distance from the system. It will cause a bad effect on their eye and make them necessary to wear spectacles at very young age. In the current scenario, there is no existing system that monitors the changes in this human body posture. In order to reduce the adverse effect caused by above discussed parameters, we have proposed this system. This is the block diagram of a proposed system. The microcontroller located at the center of the block diagram forms a control unit of the entire project. Here we are using an ARM7 microcontroller. Power supply, we are giving power supply of 3.3 volts, MEMS sensor in order to check the neck position, flex sensor in order to check the bending position, and ultrasonic sensor in order to measure the distance from the obstacle, and pulse rate sensor in order to measure the pulse rate of a human body. Sensors are mounted on the neck cap, spinal cord, and on eye. The output of these sensors given to ADC unit of a microcontroller. Based on the program embedded within the microcontroller, voltages generated by the sensors are displayed on LCD. If the voltages across the respective threshold voltage crosses, corresponding voice output is generated through MP3 player via speaker. If a person wearing this device is sitting for a long time, also then a voice output will be generated until the person changes from sitting position to standing position or do some physical activity. Voice output indicating the changes in the position is activated on periodically basis from time to time. Even the sitting posture is corrected using this equipment. Say a person wearing this device is bending more rather than sitting upright, then also the voice output will be generated insisting him or her to sit up in upright position. Ultrasonic sensor is placed above the eye to gauge for change in eye pressure. If a sensor output changes from the threshold value embedded within the microcontroller, voice output is generated from the speaker which is connected to MP3 player. These are the components used for our project. ARM7 microcontroller, it is a LPC2148 microcontroller. It is a 32-bit microcontroller which is control unit of entire project. It has 64 pins, 2 ADCs and 2 ports. And coming to the sensors, we are using MEMS sensor, ADXL330 MEMS sensor. It is a 3-axis accelerometer which is based on MEMS technology. It can measure the static acceleration of gravity in tilt sensing application and dynamic acceleration resulting from motion, shock or vibration. And flex sensor, here we are using 2.2-inch flex sensor that measures the amount of deflection or bending position. And coming to the ultrasonic sensor, here we are using HCSR04 ultrasonic sensor, which measures the distance of an object by using sound waves. And LCD, we are using 16x2 LCD. That means it can display 16 characters per line, and there are 2 such lines. And we are using speaker. Speaker receives the electrical signal from CD, DVD or from tape, and it converts them into physical vibration.
When the MEMS sensor and the flex sensor, which we have attached to the body, are in the normal position, and the ultrasonic sensor is also at a large distance from the obstacle, it checks for the position for all the 3 sensors and displays the output on the LCD as normal neck, normal body position, and the distance of the ultrasonic sensor from the body. When the MEMS sensor attached to the neck is not in a normal position and the flex sensor is also in a bent position which is attached to the backbone, and when you are too near to the system, which is it checks for the all 3 sensors and it will display a output as, and it also gives a voice message as.
This is the complete working of our project, and we would like to thank our guide, Professor Kalpavi ma'am, and our coordinator, Professor Yoganandini ma'am, and Professor Ezil sir. And we would also like to thank our HOD sir, Dr. C.V. Ravishankar, Department of ECE, and all the faculties of ECE department and our friends. And we would like to thank our principal, Dr. H.G. Chandrakant sir. Thank you.